Hey everyone, welcome to my channel. This is the final part of the self-driving car with lane detection using Raspberry Pi. So far we have learned how to find the curve value given our path. In this video we will learn how to implement this code on our Raspberry Pi self-driving car. We will also look at how we can tune our parameters to get the best results. So let's get started. So one last thing is the normalization. Because we are sending the curve values as in the range of -1 and 1, we need to change the values over here. So here if we see our curve value is ranging between 60 to -60, something like that. So what we will do is we will change it to -1 to 1. So we will say that curve is equals to curve divided by 100, let's say. So this value you can change, but I have seen that 100 is a fairly good estimate. So the last thing is that you don't want to exceed the value of 1 or -1. So you will say that if curve is greater than 1, then curve is equals to 1, and if curve is less than -1, then curve is equals to -1. So we are just limiting it so that it doesn't exceed by chance. If there is an error or something happens, it always stays between -1 and 1. So this is known as normalization. So let me write here normalization. So now that we are done with our lane detection module, let's have a look at the webcam module and the motor module that we will be using as we have discussed before. So the webcam module is basically very simple. We are importing our library CV2 and then we are using our webcam, and we have a function by the name getImage that will get the image and then it will resize it to the given specifications, and then it will return this image. And if we have chosen to display, then it will display it, otherwise it will not display. So over here you can see the implementation. So you just say image is equals to get image, and if you want to display you write true, otherwise you write false. So this is very simple. Let's look at the motor module. Now this motor module it takes a while to understand, and I have a complete video on this, how it runs. But all you need to know now is how can we send values, or how can we run this. All you have to do is you have to create a motor object where you have to define your pin numbers. So on my Raspberry Pi I have connected pin number 2, 3, 4, and then 17, 22, and 27. So you have to use the move method. So in the move method you just define the speed, and then you define the turn and the amount of seconds you want to run this function. So that is pretty much it. So here now we have the main robot lane module. So this will be our main module that will communicate with all the other modules. So the first thing we will do is we will import all the modules. So we will need the motor module, we will need the lane module, and we will need the webcam module. So because we just need the motor in our motor module and the get lane curve in our lane module, so we will just import those. Now, as I've mentioned before, the first thing you have to do, you have to define which pin numbers your motors are connected to, and then you can simply send in the curve value and the speed value. So in our main function, so as I've mentioned before, we can just write here if name is equals to main, then we will run the main. So this will keep looping. So in our main function, what we are doing is the first thing we need to get the image from our webcam. So we are saying that image is equals to webcam module dot get image, and this will store the image over here. Then we are sending this to our lane module to get our curve. So this will send us our curve value, and we have written this as 1. This is the display value. So if it is 1, it will just show the result, and if it's 2, it will show the pipeline, and if it's 0, it will not show anything. So once we have the curve value, we need to send it to our motors. So what we are doing is basically, first of all, we are defining the maximum speed. So we don't want to exceed a certain amount of speed. So our speed value ranges from 0 to 1. So then we are defining the dead zone. So the dead zone is where your car is supposed to go straight. So if we don't define any dead zone, it will keep moving a little bit right and left all the time. So what we can do is we can define a dead zone that if the value is, for example, less than 0.05, then don't move at all. Keep going straight. So the curve value will be 0. Now here you can see that we have two different dead zones. For the positive we have 0.05, and for the negative we have 0.08. And the same way we have a sensitivity. The sensitivity is how much we want to have impact of the curve. So we are simply multiplying it with the curve. Now both of them are basically different for the left side and for the right side, and the reason for that is that your motors will not run the same speed for the left and for the right. So it will have some error in between. So if you run your motor at, let's say, 50% of the speed in the forward direction, it will not move forward. It will tilt a little bit. So this is to accommodate that. So here we are simply sending the value finally to our robot or our car. We are saying motor.move, and we are giving the initial value as 0.2, and then we are going to give it the value of our curve. Now I've written minus here because my motor polarity was different. You might not need to use minus here. And then we have to give it the time. Now if you are using the display function, you have to turn on this CV2 wait key, otherwise it will not display you the output. And to do that, you also have to import your CV2 as well. So that is it. Now we can put it all together and run it in our robot. So while tuning, you will have to change quite a bit of things. So the first thing is your sensitivity. You will have to play around with this. If you put sensitivity as 1, so it will have the exact same impact as the curve value. Otherwise, if you increase, it will multiply the effect, or if you decrease, it will decrease the effect of the curve. Then you have to change the maximum value. You will see how much do you want. Keeping it at a low range is a good idea. And then we have our dead zone. So you will see which dead zones are appropriate. And the final thing is your speed at your base speed. So here you can change this based on your robot and based on the motor capabilities. You can change this value as well. So as you have seen, it is not very complicated to run a lane detection algorithm on our Raspberry Pi. So in the upcoming videos, we will look at how we can use machine learning and convolutional neural networks to actually run our lane detection as well. We will also maybe look at different techniques of basic geometrical methods of detection of lanes and curves. So stay tuned for that, and if you enjoyed this video, if you found it useful, give it a thumbs up, and if you have any questions, leave them in the comments, and I will see you in the next video.